On Earth, every person shares the exact same space-time. Because we occupy the same general environment, your experience of time is virtually identical to mine. Black holes represent a break in that shared reality. The extreme mass concentrated here warps space and time so violently that the physics we experience every day no longer apply. To see how those rules break down, we're going to perform a thought experiment. We will point our ship's engines toward a singularity and use a theoretical anti-gravity drive to survive the descent. Entering this region of gravitational warping crushes physical matter and actively slows the progression of time itself. As the ship passes the photon sphere, the last point where light can orbit the black hole, the view outside changes. The gravity is now so strong that it pulls light from the horizon and bends it downward toward the ship. This creates a massive optical illusion. The surrounding blackness appears to curve upward, making it look as if the ship has already entered the black hole when we are technically still outside. There is no physical signpost or barrier marking the event horizon. The only way to know we've reached it is by watching the window of the universe above us shrink until it becomes a single point of light. In this environment, our senses are unreliable. To navigate the edge of a singularity, we have to ignore what we see and rely strictly on the mathematics of the descent. This diagram shows our experimental setup. We have parked our ship at exactly 1.01 Schwarzschild radii, just a fraction above the event horizon, while leaving a probe in the safe space far above us. Every time the probe orbits, it sends a radio signal down to our ship. That signal is transmitted at a precise frequency of 10 megahertz. But because we are deeper in the gravity well, we receive that signal differently. Our sensors show the frequency jump to register an 83 megahertz. This shift gives us a direct measurement of time dilation. For every 1 second that passes here on the ship, 8.3 seconds have passed for the probe. This confirms that time is moving slower at the edge of the black hole relative to the rest of the universe. This happens because of a core rule of general relativity. The speed of light must be constant for every observer, no matter where they are. Since speed is a measurement of distance over time, the only way to keep the speed of light constant in extreme gravity is for the universe to change the way space and time behave. This embedding diagram shows how space curves downward into a higher dimension near a black hole. When a photon travels through this area, it has to cover all that extra distance created by the curve. To ensure the light doesn't appear to slow down while covering that extra ground, time itself slows down for the observer inside the curve. At the event horizon, the curve of space becomes completely vertical. At this point, space is essentially flowing inward at the speed of light. The event horizon is the threshold where the universe stops time to keep the speed of light from breaking its own limit. If time is standing still at the event horizon, we have to wonder what happens to a physical object that crosses it. Imagine we extend a long pole from our ship until the tip touches that boundary. To understand the result, we look at how objects move. Pushing a rod creates a pressure front of electrons pushing against others at nearly light speed. This creates a conflict. The pole's top and bottom experience time at completely different rates. In one scenario, the end of the pole at the horizon receives those pressure waves so quickly that the material simply explodes. In another, the massive difference in time acts as a physical pulling force, snapping the pole like a rope under too much tension. Solid matter cannot bridge this gap because the top and bottom of the object are being pulled through time at two different rates. This only happens if we try to hold the object still. If we let go, the pole becomes an inertial frame. It accelerates and falls into the void smoothly, just like any other matter in the universe. Black holes are more than just vacuums in space. They are points where the basic structure of our reality is forced to change. They show us that the speed of light is a constant so absolute that the universe will stretch space, tear matter apart, and stop time to preserve it.